Ladies and gentlemen, could you hear my voice clearly?
Yes. Very good.
Okay.
Yes.
Okay, thank you for joining our webinar, and we will start our webinar shortly. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. I wish you have a very pleasant morning and serenity. Welcome to DiGDaya, Diskusi Geologi Sumber Daya, Series 10. Held by Research Center for Geological Researches, National Research and Innovation Agency of Indonesia, with topic Boosting Methane Hydrate Research in Indonesia. I am Tanti and I'll be served as the webinar host today. It is an honor to me to inform you that among us here we have distinguished Head of Research Center for Geological Resources BRIN, Bapak Dr. Iwan Setiawan. Distinguished speaker, Dr. Nadezhda Syrbu from Pacific Oceanology Institute, Russia. Distinguished speaker, Dr. Feisal Dirgantara from Research Center for Geological Researches. Distinguished speaker, Dr. Zhang from Guangzhou Marine Geological Survey, China. And our respected moderator, Bapak Dr. Maruf Mukti from Research Center for Geological Resources, and all participants and guests. Well, ladies and gentlemen, please allow me to read the agenda for today's webinar. The first agenda is the opening session, and the second will be the presentation and discussion session led by our moderator. And last but not least, there's also the closing session. Distinguished ladies and gentlemen, please allow me to read the webinar rules of conduct. To all attendees, please mute your Zoom meeting. If you have any question, please type your brief question in the chat box. You may also ask the question by activating the raise hand feature on the Zoom meeting until the moderator invites you to. Please use the virtual background, and all participants are welcome to change your name into your name underscore your institution. And before we proceed our first agenda, I would like to invite all participants to sing Indonesian national anthem, Indonesia Raya. Ladies and gentlemen, we are now in the opening ceremony. As our first agenda, it's a very honor to invite distinguished head of Research Center for Geological Researchers of BRIN, Bapak Dr. Iwan Setiawan, to deliver some welcome remark and open today's webinar officially. To Pak Iwan, the time is now yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, everyone. Thank you, Mbak Kristanti. Good morning, ladies and gentlemen, colleagues, and especially for our presenters. Welcome to DiGDaya, the 10th webinar on boosting methane hydrate research in Indonesia. I appreciate our participants and speakers for their time. Special thanks to distinguished speakers, Dr. Zhang from Guangzhou Marine Geological Survey, Dr. Nadezhda Syrbu from Pacific Oceanolgy Institute, from Research Center of Geological Resources, Dr. Feisal Dirgantara, and Dr. Maruf Mukti as chair and moderator for this session. We routinely conduct this event, DiGDaya, to discuss geological survey topics of any idea about resources, from exploration, engineering, and conservation of geological resources. The Geodynamic Research Group, Research Center of Geological Resources, with Pak Maruf as the coordinator, hosted this session webinar. This session mainly aims to get the lesson from the international scientists on their experience in doing methane hydrate research. We would like to understand how the geodynamic can control the methane hydrate formation, especially in Indonesia. Methane hydrate are formed when methane and gas water mix under certain high pressure and low temperature conditions in continental marine sediments or at depth of about 200 meters at permafrost region. Until now, research and investigation of methane hydrate in Indonesia have never been brought into formal national program. The identification of methane hydrate in Indonesia mainly resulted from secondary outcomes from the Sundaland, continental margin research, and deep sea hydrothermal investigation. In BRIN, National Research and Innovation Agency, we have Research Center for Geological Resources, we have a Research Center for Oceanolgy, and we have a Research Center for Deep Sea, belong to the Research Organization of Earth and Maritime, would like to build a research collaboration on methane hydrate with Indonesia Marine Institute, Foreign Institute, and petroleum companies operating in Indonesia. The title about hydrate methane exploration, how it was formed, and how can we be extract, will be delivered by the presenters. I hope everyone can enjoy the webinar and have a very productive discussion. Thank you, everyone. I return the monitor and time to Mbak Christine. Please, Mbak Christine, you can continue.
Okay, thank you, Pak Iwan. We would like to express our gratitude to Pak Iwan for the welcome and opening remarks. Ladies and gentlemen, before we begin our main agenda, now we will take a picture together. So please, sir and madam, activate the camera and video function on your Zoom application. And I would like to invite the IT team to assist in taking a picture. Please be prepared and wait a moment and hold your best smile while our IT team in taking picture. We have 2 slides here, and I will count from 1 to 3. Yeah. Okay, I think we finished taking a picture. Thank you for your cooperation. Ladies and gentlemen, we are now reached on our main agenda. Before that, I would like to remind all the participants about the discussion session guides. Due to the time constriction, the moderator will present only selected questions to the speaker during the discussion session. And if you have any question, please type your brief question in the chat box. You may also ask the question by activating the raise hand feature on the Zoom meeting until the moderator invites you to. And all presentation and discussion will be presided over by Bapak Dr. Maruf Mukti. And please allow me to read his brief biography. Dr. Maruf Mukti is a researcher at the Research Center for Geological Research of BRIN. He holds his Bachelor of Geology degree from Pajajaran University, and as well as the Master of Earth Science degree from the Chiba University of Japan. He completed his doctoral studies in the Earth Science in the Institut de Physique du Globe de Paris, France. Ladies and gentlemen, let's welcome our moderator, Bapak Dr. Maruf Mukti.
Oke, terima kasih Mbak Tanti. So good morning everyone. Selamat pagi. Assalamualaikum warahmatullahi wabarakatuh. Bapak Ibu semuanya. So and also perhaps good afternoon for Dr. Syrbu, because I think it's already known in Vladivostok, right? So once again, I would like to say welcome to all participants, and especially for the three speakers that will have that will present their material, their slide for this morning. For Dr. Syrbu, Dr. Feisal, Dirgantara, and Dr. Zhang. So I will not take your time too much. So we will start the first talk from Dr. Syrbu. So Dr. Syrbu, are you already here, right? So I would like to. Yes. Yes. Thank you, Dr. Syrbu. So okay, the talk will be start from you. So I will mention about your CV. So Dr. Syrbu is she graduated from the Geoecology Institute from Far Eastern State Technical University of Vladivostok, and she got her PhD in geological and mineralogical science also from the same institute. So she has been a researcher in the POI FEB, so it's a Far Eastern State Technical University Vladivostok from 2007, and then now she's a project leader in geoecological, geochemical, hydrothermal, and gas hydrate research in Sakhalin and Hokkaido and North Vietnam. So I believe she has many experience in gas hydrate research. So we will be very happy, Dr. Syrbu, to have your have your share about all methane hydrate in Russia. So you have like 25 to 30 minutes for your slide, and you may continue from now on. Please, Dr. Syrbu.
Yes, dear colleagues, hello everyone. Wait a minute. It's okay?
Yes, it's okay. Perfect. It's perfect.
Yeah. Okay. I want to thank you, first of all, for the opportunity to share the research of POI. I work in the field of marine geology and gas hydrate research. At the moment, I'm the head of the laboratory. We have a young but very experienced and energetic team. We conduct multidisciplinary research at the intersection of several sciences: geochemistry, microbiology, chemistry, and remote sensing. Today, I want to present you an overview of gas hydrates of the marginal seas of the Western Pacific. POI has high competence and a great experience in marine research. Many indigenous employees also take part in expeditions, for example, from Buryatia and Yakutia regions. We study geology, geophysics, geochemistry, geomicrobiology of the Pacific, Eastern Arctic, and its mineral resources. Special attention we pay to gas hydrates, gas geochemistry, and mineral resources. Since 1960, 1984, the research team of POI has been involved in oil and gas exploration work of the northern of Pacific Ocean. A method of searching for oil and gas deposits according to a set of gas geochemical criteria was developed by Dr. Abzhirov. We discovered a sharp increase in the values of a background and abnormal concentration of methane in the bottom layer of the northeastern shelf and the slope of Sakhalin Island. This indicates the beginning of the cycle of a seismic tectonic activation of the region. Our team took part in a number of international projects, in a Russian project supported by different grants. Gas hydrates in the western part of the Sea of Okhotsk was the most fully explored first time during this project. The worldwide gas occurrence is very large. The accumulations of gas hydrate and marine sediments is controlled by number of physical and biochemical parameters, and also active pole. Along the western part of the Pacific Ocean, there are many marginal seas associated with the destructive crust of oceanic and continental types, the gas hydrate potential of which has not been yet studied. One of the first discoveries of gas hydrates were made on board a research vessel Marine Geophysics in the Sea of Okhotsk. Therefore, at the moment, we have several reasons for a complex study of marine gas hydrates in the Indo-Pacific region. Gas hydrates are important marine phenomena, and gas hydrates were found in many areas of the Western Pacific and Indian Oceans. Nature and evolution of gas hydrate system in the lithosphere and hydrosphere, which in respect to environment agent is one of the most uncertain problems of the world ocean today. Fluxes of methane are associated with gas hydrates and plays a significant climatic and social role, but remains one of the most debated topics now. First of all, we
Dr. Syrbu, you're freezing. Dr. Syrbu?
Sepertinya terkendala koneksi ya, Dr.
Ya,
Nadezhda.
sepertinya ada masalah nih. Oke, sepertinya ada masalah mic. Kita tunggu sebentar saja ya, Bapak dan Ibu. Jadi sambil menunggu Dr. Syrbu kembali lagi ke ini, jadi para pemateri ini adalah kolega dari Pak Susilo Hadi. Jadi beliau adalah peneliti senior di kelompok kami di Geodinamika di Pusat Riset Sumber Daya Geologi. Jadi sepertinya kalau kerjasama itu sudah terjalin Pak ya, Pak Susilo, antara Indonesia dengan Rusia, atau ini memang akan menuju kerjasama ya?
Kita sebetulnya dalam kerangka working group di dalam IOC Westpac. Jadi regional office dari IOC itu di Asia Barat itu namanya IOC Westpac.
Ya.
Dan oleh IOC Westpac dibentuk beberapa working group. Salah satunya adalah mengenai methane hydrate dan methane flux. Ini merangkum banyak member states di sana untuk bergabung dalam working group. Sebetulnya working group belum lama dibentuk, baru mulai tahun 2021 untuk jangka waktu 2 tahun, dan sebetulnya tahun ini sudah berakhir, tetapi diperpanjang 2 tahun lagi. Kita sebetulnya baru bergabung awal tahun lalu, dan saya harap ini bisa kita manfaatkan untuk pertukaran kegiatan keilmiahan ini.
Tadi Pak Susilo sebutkan working group itu apa bekerja untuk 2 tahun Pak ya?
Iya, untuk
Dengan waktu sependek itu sebenarnya
Syrbu udah
harapannya.
ada Pak Maruf.
Oh udah ada ya?
Iya.
Baik sebentar. Terima kasih Pak Kapus. Dr. Syrbu.
Yes, I'm so sorry. I have a big problems with internet connection now.
Oh, it's
Is this
fine.
okay? Do you hear me? Okay.
Yes, we can hear you.
I can continue, yeah?
Yes, of course. You may continue your slide.
Thank you.
Welcome.
PI has a great experience in marine research and studying gas hydrates in the frame of international programs at Russian Scientific Foundation. We conduct all seasons marine expedition. Methane hydrates was explored since 1860. Gas hydrates supplying fluid within the thick Cainozoic sediment basins are linked to hydrocarbon accumulations, mainly oil and gas deposits and gas hydrates, provided for Bering, Okhotsk, and Japan seas and numerous Arctic seas. Western and eastern margins of Pacific Ocean present new gas hydrate sites distributed gas hydrate provinces which can be combined to second Pacific gas hydrate belt. Gas hydrates accumulations induced by various. Okay,
So,
yes.
Yeah, sorry to interrupt, but probably you can turn off your camera, so to make it the bandwidth better, the internet connection. If you want to turn off, yes, your
now,
video.
no?
Yeah, it's a bit free sometimes. So okay, you may continue.
But my okay. Wait a minute. Wait a minute. What I meant. Bering Sea, Okhotsk Sea, Japan Sea, East China Sea, Sea of Vietnam, Philippines, and Sulu Sea, and so New Zealand offshore present the Western Pacific gas hydrate belt and expose methane hydrate distribution in sediments. Gas hydrate in Japan Sea and Sea of Okhotsk originate from gas flux from interior gas combinations. You can see it on the slide. Gas flares within Western Kuril Basin slope were registered at a depth from 2,000 to 200 meters. The maximum concentration was observed in northwestern corner of the Kuril Basin. Gas flares were located on the Shelf Bridge and on the northern flank of the Dirgantara Canyon. In this area, we found maybe the highest flare among all known gas flares on eastern Sakhalin slope, and its height was 2,000 meters.
It seems sepertinya terputus lagi ya koneksinya.
Rusia juga sama ya.
Oke. Baik, mari kita tunggu saja ya. Sambil menunggu ini Pak Susilo mungkin tadi bisa kita lanjut obrolan kita tadi mengenai working group yang dari IOC itu yang terkait dengan grup yang Bapak ikuti. Jadi mungkin juga bisa menambah informasi untuk Bapak Ibu yang ada hadir di sini.
Ya, betul. Jadi ini sebetulnya kesempatan buat kita semua untuk memperbaiki iklim penelitian kita mengenai methane hydrate di Indonesia. Karena sampai sekarang memang interest untuk meneliti methane hydrate maupun methane flux di Indonesia itu sangat-sangat sedikit sekali. Mungkin karena memang biaya penelitiannya sangat mahal, karena ini menyangkut laut dalam. Karena biasanya methane hydrate di daerah tropis mungkin berada di kedalaman yang cukup dalam. Untuk sementara ini, memang kita hanya bisa mengidentifikasi dari data-data seismik di laut dalam. Tetapi kita berharap kalau kita punya kapal riset nanti, mungkin 2 atau 3 tahun lagi, kita bisa mengambil contoh hidratnya sendiri. Mudah-mudahan bisa kita teliti lebih real, jadi bisa kita lihat barangnya, dan mudah-mudahan potensinya juga bisa kita hitung, termasuk juga mungkin efek methane hydrate ini terhadap lingkungan di sekitar kita.
Baik.
Sebenarnya harapan satu lagi dengan adanya presentasi ini, mudah-mudahan kita bisa membentuk working group, national working group sendiri sebenarnya untuk membangun jejaring penelitian methane hydrate. Karena saya yakin data yang ada, data seismik terutama, itu pasti tersebar di banyak lembaga di Indonesia. Jadi mau tidak mau untuk mempersatukan ini, mesti ada satu working group sendiri. Saya kira begitu, Pak.
Oh ya, baik. Ini baik sekali itu tujuan akhirnya untuk membentuk satu working group sendiri di kita secara nasional. Tapi ke arah sana sepertinya sudah sampai mana ya Pak Susilo? Jadi apakah memang sudah ada pembicaraan di antara ini, antara institusi yang ada?
Belum jauh Pak Maruf. Mungkin karena saya berasal dari Kementerian SDM, baru teman-teman dari Kementerian SDM saja yang
Oke, baik. Pak Susilo, ini sepertinya Dr. Syrbu sudah ada kembali dengan kita. Dr. Syrbu?
Yes, here. I'm so sorry. I don't know what to do. Maybe I should to stop video.
Yes, I think you can stop your video and only share your slide. Perhaps it will be much better.
Okay. Submarine gas seepage usually accompanied by contrast seismic and acoustic anomalies in sediments. For example, about 700 gas layers indicates gas hydrofracture accumulation in Western Okhotsk Sea.
Actually, we're still waiting for your slide, Dr. Syrbu. It's still, yeah, because it's still blank on the monitor. I cannot see yours. Okay, now it's coming. Okay.
Yes, you can see location
now.
of reveal gas hydrate accumulation. Yes.
Yes, we can see it now.
And some gas flares in the northern eastern Sakhalin slope, in the western slope of Kuril Basin, and near Peremushil Island. This refers to the main fault zones. Gas hydrates and related methane.
Bu Maruf izin barangkali bisa nanti dikirim slide-nya. Nanti kami asistensi untuk share screen-nya begitu.
Oke. Coba nanti yang Pak Susilo. Mohon maaf Pak Susilo. Karena kontak-kontaknya pasti lewat email, jadi mungkin tidak secepat itu kita bisa meminta beliau.
Iya.
Ya, bisa lewat email.
Ya, itu dia. Okay, she's back. Okay. Dr. Syrbu?
Most intensive mistake. Yes. Yes.
Yes, it's coming. Yeah, we can see your slide now. But could you please turn on the slide view, the slideshow?
Do you see now? Yes. Oh.
We can see you, but we cannot hear your voice clearly. Now it's gone. Now it's blank again.
Now?
Still waiting.
Mm. Do you see my translation now?
No, we're still waiting for your slide. The monitor is still blank. We cannot see your slide.
Okay.
And your voice, we have difficulty to hear your voice actually. It's a bit disconnected sometimes. So
I can see.
I think yeah, there's the internet connection probably not stable. So
Yes.
could you share your slide
Send it to me.
so we can show it from here?
I try.
Mhm.
No? And now?
No, it's still blank actually.
Oh, too bad. Maybe I need to reconnect for this. Yes, no?
Oh.
It's still blank?
Yes, it's still blank. We cannot see your slide. If you're okay, could you share your slide to us and then we can share it on the screen on Zoom for everyone?
By mail.
Yeah, mail to me, to Susilo Hadi.
Okay. Let's do this.
Silakan Pak Susilo nanti kirim ke Haris ya atau ke grup biar nanti saya share screen.
Atau ditunda dulu biar terpisah dulu atau Faisal dulu.
Oke, kalau memang beliau tidak keberatan, Pak Susilo. Kalau memang beliau tidak keberatan, kita bisa lanjut dulu dengan Mas Feisal, kemudian kita lanjut dengan Dr. Zhang, dan Dr. Syrbu nanti yang terakhir ya.
Ya.
Saya nggak masalah, Pak.
Oke. Baik, panitia gimana? Kita tukar saja ya.
Ya, di switch saja, Kang.
Ya, baik. Kalau gitu, Mas Feisal. Oke, baik, Bapak Ibu. So, ladies and gentlemen, I'm sorry for the technical problem. So we have to because we don't have so much time. So we change Dr. Syrbu talk with Dr. Feisal. So Dr. Feisal is the youngest in our member. So he just joined our research group. He got his bachelor degree from Gajah Mada University, and then he completed his PhD in Taiwan. He has many research experiences, especially related to seismic imaging and methane hydrate in Taiwan, also New Zealand. And he also has several experiences in oil and industry before he took his PhD. So I'm not taking your time too much. So Dr. Feisal, you can continue your slide. You have like 25-30 minutes for your talk. You can continue now, please.
Let me share my screen.
Okay.
So is it visible to all of you?
It's okay, but we still have that black box in the middle of the slide.
Okay,
It's on top. Okay, now it's perfect.
Yeah. Okay,
Silakan.
All right.
There's a black box in the middle of the slide. Could you please? Okay, that's good.
Is it on now?
Yes, Mas. Silakan.
So let me turn off the video just in case something bad happened. All right. So I will start now. So I'm the second speaker. Good morning, people. My name is Feisal Dirgantara. I am a postdoctoral researcher at the Research Center for Geological Resources of National Research and Innovation Agency of Indonesia. Today, I would like to introduce the preliminary result of the gas hydrate study in South Makassar Basin that I've been working over the past 1.5 months. I will start the talk by introducing the history of gas hydrate study in Indonesia. The first attempts were made during the deep sea drilling project in Timor Trust back in 1980, where isotope analysis confirmed the presence of dissociated biogenic methane hydrates. And then in 1985, Chopra et al. Utilized reflection seismic data to study the Andaman 4 arc basin and identified gas hydrates based on bottom simulating reflectors. Subsequent drilling in 2006 validated these findings in the Andaman 4 arc basin. Since then, methane hydrate potential have been reported in various 4 arc basins, including in Mentawai, Bengkulu, Java, Aru, and also North Sulawesi. In the Makassar Strait, a failed reef basin, similar potential was identified and drilled back in 2011. Despite extensive research and the establishment of regulatory frameworks in 2012, Indonesia has not actively pursued the exploration and exploitation of these valuable natural resources. Currently, efforts in this field are primarily conducted through independent studies by domestic and international researchers. Despite the fact of that, Ministry of Energy and Mineral Resources of Indonesia has estimated a methane hydrate reserve to be around 850 trillion cubic feet. And during this talk, I will focus on the specific area marked by the red square. So gas hydrate by definition is a natural gases trapped within ice cage structures formed under specific pressure and temperature conditions. Their immense potential as a natural gas source has garnered significant interest due to the energy resource implications that they hold. In this talk, I will specifically address 2 objectives. The first, I will explore the seismic characters associated with gas hydrates in relation to the plate types. And also, secondly, I will delve into investigating the thermal properties from BSR derivations and compare them with the references. The study area is located in the South Makassar Basin, which is a Cenozoic extensional deep water basin. It is bounded to the west by Borneo and the Patinosphere platform, and to the east by the collisional complex of Syrbu. The Adang Fault, a transtensional sinistral strike slip fault, separates the basin from its northern counterpart. In general speaking, the Makassar Strait began opening during the Eocene, preceding the onset of compression in the late Miocene to Pliocene. This compression resulted in the development of a fold and thrust belt along the eastern margin, starting from the North Makassar Basin to the South Makassar Basin. As a consequence of this tectonic shift, the study area exhibits a failed reef system. It is predominantly characterized by a deep sea sedimentary complex with an average sedimentation rate of 0.3 to 1 millimeter per year. Exploration efforts in South Makassar Basin have garnered less attention compared to the North Makassar Basin. In 2011, 6 drilling attempts resulted in dry holes or uneconomical wells, which significantly impacted further exploration activities in the area. However, 2 of these drilling campaigns confirmed the presence of gas hydrates potentials in our study area. Additionally, an airborne laser fluorescence survey indicated by this white polygon has revealed hydrocarbon seepage in the same region. The area of interest covers approximately 27,000 square kilometers, with water depth varies between 5 meter to 2 kilometer. Data utilized in this study include 13 2D seismic pre-stack time migrated section with total length about 2,000 kilometer, and then 4 exploration wells, and then 17 references of thermal properties in the offshore territory of Indonesia, Southeast Asia, Northern Australia, and also New Guinea. Here is the simplified workflow of this project. The red line separates the scope of work that I will be discussing today from what I plan to explore in the near future. This talk will primarily focus on the preliminary interpretation on the gas hydrate clay types and the discrepancy between thermal properties derived from BSR versus the one compiled from the references. In the future, I intend to integrate well data to gain better understanding of the gas hydrate system. This will be followed by seismic attribute analysis and theoretical assessment of the gas hydrate stability zone. Ultimately, the goal is to estimate the volumetric potential of the gas hydrate reserve in the study area. To initiate the study, I focused on identifying the presence of bottom stimulating reflectors, or also known as BSR, within the reflection seismic data. The provided figure represents an example of one of the seismic lines where BSR are particularly well identified. The BSR exhibit a unique characteristic of resembling the seafloor topography with a reversal polarity, indicating the probable existence of high acoustic impedance hydrate over low impedance free gas. These BSRs are often observed to cut cross geological reflectors, as demonstrated in this case, where they intersect this folded strata. Additionally, there is an enhancement of reflections below the BSR, which suggests the presence of gas charging sands within the folded strata. Based on the interpretations of the reflection seismic data, the seafloor depth within the study area ranges between 18 meter to 2 kilometer, and then the depth of BSR varies between 300 and 420 milliseconds. If we assume the average sediment velocity and the near seafloor is around 2000, then we will have the BSR depth around 300 to 420 meter. It is noteworthy to mention that in the seismic line CM01, it doesn't exhibit the presence of BSR. This absence could be attributed to the relatively shallow bathymetry in that specific location, which may hinder the accumulation of sufficient hydrostatic pressure necessary for the formation of the gas hydrates. Furthermore, even when gas hydrates are present, their distributions is not always continuous, but rather localized. This suggests that the occurrence of gas hydrates within the study area is not uniform, is non-unique, and may be influenced by specific geological and geophysical factors. Through seismic interpretations, the study area exhibits at least 6 gas hydrates types. The first is the basin margin type. In this type, the inclined beds at the basin margin have a higher dip angle compared to the interior part compared to the center part of the basin. This inclination makes it relatively easier to distinguish the presence of BSR, In contrast, if we move into the depot center part of the basin, it becomes more challenging to identify the BSR. Why? Because the stridal reflections in those areas often parallel to the seabed. So we cannot really see the BSR quite clear. The second gas hydrate clay type observed in the study area is the polygonal fault type. It is likely formed due to gravity-driven differential compaction, as well as possibly extensive dewatering processes. These polygonal faults provide pathways for fluid migrations. And then the third gas hydrate clay type in the study area is similar to the previous one, the polygonal fault type. But in this case, we have the additions of buried carbonate mound at greater depths. This mound may act as a source rock for the deep-seated thermogenic gases, contributing to the formations of gas hydrates when they are migrating upward. The fourth gas hydrate clay type in the study area is the slope type. It is characterized by slopes with shelfward dipping strata. This configuration facilitates the upward gas migration along the strata, contributing to the formation and the concentrations of the gas hydrates. The next type is the sediment waves types. So sediment waves, according to many references in the Makassar Strait, are suggested to be the result of interaction between turbidity currents such as bottom current and the seafloor. In different gas hydrate prospects around the world, topographic high and crest of sediment waves often serve as preferential location for the trapping and the preservation of gas hydrates. The final gas hydrate clay type observed in the buried anticlinal type is the buried anticlinal type, and it is likely associated with the distal fall and thrust belts in the western syllabus. This buried anticline offer potential reservoirs for the gas hydrate accumulations within the folded and deformed rock layers. So that's all the 6 gas hydrate clay types, and then move on regarding the gas origin. So in Makassar Strait, the hydrocarbon sources are believed to have both thermogenic and also biogenic origins. The migration pathways for deep-seated gas are significant and typically involve polygonal faults and also fall and thrust belts. So these structures, they play a crucial role in allowing the migration of the hydrocarbons to the shallower depths. On the other hand, biogenic gas is also associated with hemipelagic sediments found at shallower depths. Now we are switching gear and talking about the thermal properties. So after obtaining the depth of the BSR, I proceeded the workflow described by Dirgantara et al. In 2020. And then I utilized the approach proposed by Hamilton in 1980 and gave it in 2005 to derive BSR depth. And then additionally, I employed the method presented by Davis et al. In 1980 to estimate the thermal conductivity. And then using the derived temperature values at the seafloor and the depth of the BSR, I was able to calculate the proxy for geothermal gradients. This information is cardinal when deriving theoretical gas hydrate stability zones in the later stage. Based on the theoretical calculation, the heat flow within the study area is estimated to range about 15 to 112 with an average value of 93 milliwatt per square meters. To visualize the relationship between seafloor water depth and also BSR depth, I utilized the crossplot developed by Xu et al. In 2006. In this crossplot, the dashed curves represent the calculated geothermal gradient within represent the calculated gas hydrate stability curves, which are determined based on the different theoretical heat flow values. And then conversely, I can also calculate and derive the geothermal gradient within the study area, which ranges ranging from 37 to 101 degrees Celsius per kilometer, with an average of 78. Now, with regards to the thermal references that I have mentioned earlier, to overcome the limited thermal measurements in the study area, I compiled 17 references of the thermal properties in and around Indonesia, resulting in 4,900 calculated and interpolated data points. So this small dots that you see on this map, they are the data points. And 85% of them are located in the western part of Indonesia. So within this study area, let's just focus on this red block. So within this study area, there are 14 representative data points that indicate heat flow ranging from 42 to 81 with an average of 66 milliwatt per square meter. So comparing this map to the BSR-derived heat flow, where earlier I mentioned that we have the average BSR-derived heat flow of 93. So there is a 40% higher value, possibly due to the variability of methodological approaches. So the references here in the study area, they were utilizing shallow coring down to 2 meters below the seafloor, whereas in my calculations, they were based on the BSR, which ranges around 300 to 420 meters. And that's why there will be a bias in terms of the heat flow derivation. Additionally, the limited depth of the penetrations from the shallow coring possess reliability limitations. Despite these existing limitations, nevertheless, this map serves as the current reference for understanding the thermal properties in the Indonesian water body. And for gas hydrate study, it is very important to understand this thermal properties distributions, as it controls the gas hydrate stability zone. Interestingly, the average geothermal gradient derived from BSRs, they matches with the geothermal gradient values from the references. So they are approximately at around 78 Celsius per kilometer. So it suggests that despite having a very contrasting or very different heat flow, but the geothermal gradient can be the same. So why is that? So it tells that the thermal conductivity in this area, especially in Indonesia in general, they play a crucial role in determining the heat flow values. In this case, the BSR derived from thermal conductivity from my calculations is approximately 30% higher compared to the references. So that is why in the earlier slide, you will see the heat flow from the references is lower than my heat flow. So to end my talk, I will be giving you a few takeaways. First, we have learned together that the gas hydrate formation in South Makassar Basin is associated with at least 6 play types. They are basin margin type, polygonal fault type, buried carbonate mound type, slope type, sediment waste type, and buried anticline type. And then as for the BSR, they are located at the depth around 300 to 420 milliseconds subsea floor, so it's below seafloor. And then the BSR-derived heat flow exhibit higher average value by 40% compared to the reference, despite having similar geothermal gradient trends. So this can be attributed perhaps by the variation in the methodological approaches, as I have mentioned earlier, and then the discrepancy in the depth measurement and also the thermal conductivity values. So by this, I will proceed to the later stage according to the workflow, which is investigating the gas hydrate systems. And that's the end of my talk, and that concludes my talk. I will now hand it back to our moderator for to carry us forward. Thank you so much for your attention.
Thank you very much, Mas Feisal. It's very interesting finding that you share with us. I'm sure that the audience will have a lot of questions to you, but now we will continue our talk with Dr. Wei Zhang, or Dr. Wei Zhang. Dr. Wei Zhang, are you? Are you here now?
Yeah, I can hear you.
Okay, so is it okay? So before you can start your slide, so I just want to read your short CV for the audience. So Dr. Zhang graduated from the Geographical Science of Jinan University in China, and then he completed his PhD degree in Petroleum and Gas Hydrate in Chinese Academy of Sciences, and then continue doing postdoc research in gas hydrate until now. So now he's a senior engineer in the Guangzhou Marine Geological Survey in China. So Dr. Zhang will share with us his knowledge on gas hydrate. So you have 25 or 30 minutes for your slide, Dr. Zhang.
Thank you.
So you may,
I will
okay.
share my screen.
Okay, please.
Can you see the first screen?
Yes, it's perfect. I just have to start your the slideshow. Could you please push the slideshow button?
Okay.
So
Can
we
I
can
start?
have it in full screen. So it's not in full screen, Dr. Zhang.
Okay. Thank you. Thank you your introduction. Good morning, everyone.
Dr. Zhang, excuse me. Could you make it a slideshow to make it full screen? Your slide, please.
It's not a first screen.
No, it's not full screen. So you have to click the slideshow button. I think it's on the bottom right somewhere.
Hold on, please.
Yes. Take your time.
全屏是怎么搞？我先退出来吗？再听，然后然后再就重新点这个，用这个屏幕，我再找个语气，这个可以就是有。Hello, is okay?
We are waiting. It's still blank now. It's coming probably. It's still blank.
They're blank.
Yes, we still cannot see your slide. So.
也没有，还是没有。调不了了。变区。是国内这种东西。
Is there any problem, Dr. Zhang?
Sorry, I can't share my slides. There is a problem. Please wait a moment.
Okay.
Maybe I should equip the Zoom meeting and attend the meeting again.
Okay. We'll be waiting for you. Bapak Ibu, kita tunggu sebentar ya. Sambil menunggu, mungkin Pak kembali lagi Pak Susilo, kita bisa kita kembali lagi Dr. Zhang ya. Oke, Dr. Zhang. If you cannot show the slideshow, then it's okay. You can present your slide just like this. It's fine. Dr. Zhang?
Yeah.
Are you here with us? Okay. You can show your slide just like this. It's okay. It's fine.
Okay.
Okay, so you may continue your slide.
Okay. Let's begin. Good morning, everyone. It's my honor to have the opportunity to give a presentation in the gas hydrate research webinar. Today, I share with you the research progresses and experiences in offshore gas hydrate exploration in the South China Sea. My presentation is in 3 parts. Firstly, I will show the progress of hydrate exploration and development in the northern South China Sea. Secondly, I'd like to introduce the gas hydrate research technologies and experience. Sorry.
Yes, Dr. Zhang, is there any problem? Dr. Zhang?
Yeah, I'm back.
Okay.
Secondly, I'd like to introduce the gas hydrate research technologies and experience in the northern South China Sea. Finally, I propose the future research cooperation in the field of hydrates between Indonesia and China. First of all, I'd like to briefly introduce myself and my institution. My name is Zhang, a senior engineer from Guangzhou Marine Geological Survey. I have been working on gas hydrates, oil and gas in the South China Sea for nearly 10 years. The GMGS, under the director control of China Geological Survey, Ministry of Natural Resources, is a comprehensive scientific institution which conducts national basic, strategic, and public beneficial investigation and research of marine geology. The GMGS possesses 2 bases in Guangzhou and Sanya, respectively. And most of the researchers work in the Guangzhou base. In addition, 2 wharfs have been constructed by the GMGS in Guangdong. Guangzhou Course for Geological Survey. The GMGS possesses 9 specialized hydrate survey visas, forming an advanced marine gas hydrate integrated detection equipment system.
We still watching the first slide.
Dr. Zhang,
Yeah.
you haven't. It's still your first page of your slide. Are you still on the first page, or actually you are already changed your slide?
Sorry.
Because in our screen it's still your first page of your slide. So Dr. Zhang, is there anything we can help? Perhaps you can share your slide with us, and then we can share it from here if you are okay with this. Dr. Zhang, can you hear me?
Oh,
No.
Okay, I can hear you.
Okay, so is there any? If you're okay, you can share your slide with us, and we can share it from here if you okay with that. But you can try again to share your slide, of course.
Yeah, sure.
I think you can make it in PDF format to make the slide smaller size.
Baik, Bapak Ibu, mohon maaf atas ini masalah teknis, kita tunggu sebentar ya. Pak Susilo, sambil menunggu mungkin kita bisa berbincang lagi, meneruskan obrolan kita tadi mengenai working group yang sedang dibangun oleh Pak Susilo dan kawan-kawan. Mungkin ada yang bisa dibagi juga dengan kami di sini.
Yes, iya baik Pak. Oh,
Oke, tapi ini sudah muncul. Oke, Dr. Zhang?
Can you see the slides?
We can see the slide, but actually it's the presenter view, so it's a bit smaller. So if you can switch it.
Okay, thank you. Sorry for the turbulence. I continue to introduce the institution of the Marine Geological Survey.
Excuse me, but Dr. Zhang, can you switch to slide view rather than this presenter view? Because it's a bit smaller for the audience to see. still in presenter view, but if you have difficulty on that, well, we can continue just like this. It's fine. Dr. Zhang, just you can continue like this. It's okay.
Yeah. Is also blank.
Yes, it's blank now. So yes, it's blank. So you can share with us the slide if you want. We can share it from here if you want. If you're okay, of course. Otherwise, we'll keep waiting for your slide. So. Mohon maaf Bapak Ibu, kami minta waktunya sebentar untuk menyelesaikan masalah teknis ini sepertinya ya. Okay, Dr. Zhang, we can see. Okay, perfect. Yes, it's perfect.
Okay.
It's perfect. Yes, please.
Okay, I continue to introduce the Guangzhou Marine Geological Survey. The GMGS under the direct control of China Geological Survey, Ministry of Natural Resources, is a comprehensive scientific institution which conducts national basic, strategic, and public beneficial geological investigation and research of marine geology. Guangzhou, the GMGS constructed two bases in Guangzhou and Sanya, respectively, and most of the researchers work in the Guangzhou base. In addition, two works have been contracted by the GMGS in Guangdong province for geological survey. The GMGS possesses line specialized hydrate survey vessels, forming an advanced marine gas hydrate integrated detection equipment system. Natural gas hydrate is an internationally recognized efficient and clean new energy source. Major countries in the world have invested a lot of resources in hydrate exploration and development research. The United States, Canada, Japan, and China are competing in the test mining of hydrate. Especially, China has achieved two successful test mining of marine hydrate, which has greatly promoted the industrialization process of hydrates. The research on gas hydrate in China was began from 1995. Many important research programs on gas hydrates have been carried out in the past 2 decades. The first time for geological survey was in 1999. Since then, 8 hydrate drilling expeditions in total have been implemented in the northern South China Sea. We have recovered offshore hydrate samples for the first time in 2007 during GMS-JS1 expedition. In 2017 and then 2020, we have fulfilled 2 successful offshore hydrate production tests in the South China Sea. Since 1999, the GMGS has continually conducted the exploration and comprehensive evaluation of gas hydrate in the South China Sea. In total, the survey grades and the survey size cover the whole northern slope areas of Southern China Sea. More than 20 favorable areas with great gas hydrate potential have been confirmed. The survey grades are composed of 2-degree and 3-degree surveys. We have also established a stereoscopic hydrate detection technology system, including high-resolution seismic survey, multiple sub-bottom profile, and so on. As I said that 8 hydrate drilling expeditions have been carried out in the northern South China Sea. Multiple occurrences of gas hydrates, including porphyrin, filling, have been discovered in the Syrbu area, Dongshan area, and the Qingdong area in the northern South China Sea, with a great resource potential. Syrbu area was the first area that we have recovered hydrate samples in 2007 in the South China Sea. 5 gas hydrate drilling expeditions, GS 1, 3, 4, 5, and 6 have been conducted in the Syrbu area, and more than 40 boreholes have been drilled in this area, porphyrin gas hydrates with high saturation up to 76% have been recovered from fine-grained sediments deposited in the China New system. In 2013, we have carried out a GS2 gas hydrate drilling expedition in the Dongshan area. 13 sites have been drilled and logged, which confirmed the accumulation of filling hydrates in the eastern Pearl River mouth basin for the first time. In recent years, we have made many important breakthroughs in hydrate exploration in Qingdong Basin. Several 2D and 3D seismic surveys have been implemented in the deepwater Qingdong area. The huge Haima coast reef was covered by ROV in 2015. GS 5 and 6 expeditions confirmed the favorable distribution area of gas hydrate in the Qingdong area. Gas hydrate with multiple occurrences have been recovered in chimney zones. Based on nearly 20 years of hydrate exploration and development research, we conducted 2 offshore hydrate production tests in the northern South China Sea. In 2017, the first offshore hydrate production test was successfully conducted in the Syrbu area that is located in the middle of the continental slope of northern South China Sea. The reservoir is 6.41 kilometers in area. The thickest place nearby were W11, where the maximum thickness was up to 95 meters. The first test production set a world record of 39,000 cubic meters of gas produced continuously for 60 days, and the maximum yield is 35,000 cubic meters per day. And the China Geological Survey, using the drilling platform Blue Whale 1, conducted the first production test of offshore gas hydrate by applying the formation fluid extraction method. A number of important techniques, including deep drilling, cementing, sand controlling, depressurization, were developed during the production test, thus technically guaranteeing successful production test. In 2019 and 2020, the CGS conducted the second production test in the same ore body in the Syrbu area. Several new real-world records have been achieved again. A highly quality horizontal well with a large diameter and a high curvature was successfully constructed in shallow soft structure in deep sea by applying the built-up technology for directional wells independently developed. Last, I'd like to introduce the gas hydrate research technologies and experience applied by the GMGS during hydrate exploration in the South China Sea. Based on the hydrate accumulation characteristics in the northern South China Sea, through more than 20 years of exploration, we have established an integrated stereoscopic exploration method system for offshore gas hydrate. We have achieved stereo detection and study of hydrate system, including the hydrate reservoir, subsurface, seabed, water column, and sea surface. The GIMGES independently makes research and development of a number of key technologies for the detection of hydrate. The initial creation of a comprehensive marine hydrate detection technology system, including geophysical survey, sampling and draining, geochemistry survey, and so on. Most importantly, we have applied many geophysical survey methods, including 2D and 3D seismic, OBS, CSEM, multi-beam heat flow measurements, and MWD as well as LWD. For marine hydrants, the seismic survey is the most useful and valid method. 2D multi-channel seismic survey and exploration are applied in the preliminary stage for hydrate exploration to determine the characteristics of hydrate distribution and key areas. Then 3D or quasi-3D multi-dimensional seismic accurately characterize hydrate reservoir and internal structures, determine the distribution of hydrate and free gas, and provide accurate data for drilling site selection. The GIMGES have developed a high-resolution 3D seismic detection system, which have been effectively applied in the field of hydrate exploration in the northern South China Sea. In addition, 3D seismic and the OBS joint exploration method have been successfully implemented, and the OBS detections can obtain shear wave information and more accurately characterize the internal structure of the hydrate reservoir. To quickly identify favorable hydrate potential areas, the GIMGES developed and improved the marine controlled source electromagnetic method. The geological structure of the sub-bottom sediments is detected by using different conductivity of different media, and hydrate distribution areas can be determined in general based on this principle. Multi-beam technology is acoustic transducers to form a fan beam perpendicular to the direction of the ship. In real time to map the topography of the seafloor with high accuracy. We have applied multi-beam method to find special microtopography such as plumes, coast seeps, polemarks, mud volcanoes, complex crust. This method has played a great role in the discovery and study of the high mark coast seep. In addition, side scan circulars and sub-bottom profiles are also applied in the field of hydrate research, which effectively improve detection accuracy and resolution, large coverage, and high measurement efficiency. Additionally, based on the principle of hydroacoustic, underwater shallow stratigraphic structures are detected by autonomous underwater vehicle. Remotely operated vehicles, often known as underwater robots, are together the vehicles controlled remotely by operators aboard ships or offshore while exploring marine environments, topography, and geomorphology measurements, geological autocross observation, biomarker capture, sampling, and ordinary deep-sea engineering operations can be done with the help of the ROV during hydrate research. For the discovery of high mark coast seep and associated hydrates in 2015, ROVs assist in mapping three-dimensional distribution of gas hydrates, allowing their interactions with adjacent solid particles or mobile sediments, and capturing dynamic events triggered by warming ocean temperatures, tectonic stress perturbations, changing pore pressures, soil migration, and freshwater influx vector reactions. Geothermal measurements form an integral part of characterization and investigating lateral occurring gas hydrates in various settings. Temperature serves as one of the fundamental factors controlling the stability and the extensive of solid hybrid phases with subterranean materials, and obtaining accurate readings of both environmental heat flux and heat flow anomalies around prospective hybrid localities helps hydrologists discern favorable scenarios for gas inclusion, trapping in liquid brine or solid fabrics. Conventional methods, including inserting thermocouples, resistance temperature detectors, fiber optics, or thermistors into borehole walls, sediment cores, or Parker apparatus inserted among aquifer sand grains. Data collection strategies may entail single-point sampling over selected periods of time or deployment of multiple probes distributed along transient lines or inside a horizontal RV for 3D modeling objectives. Geological sampling, also referred to as subsurface testing or site characterization, represents a critical stage when determining whether gas hydrates occur within specific layers of strata or rock material. This activity involves extracting physical specimens or representing the target stratigraphy and evaluating these samples using a combination of analytical procedures and diagnostic tools, both offshore and onboard. Various approaches can be applied depending on the situation, such as the master style grabbing, physical sampling, and trawl sampling, and so on. Then, deep drilling and logging represent vital components of exploratory campaigns focused on characterizing and mapping natural gas hydrates. These activities help us better understand their genesis, occurrence, distribution, behavior, and the interactions with surrounding environments under variable geological, thermodynamic, and climatic controls. Oceanolgy pairs occurring electrodes placed in parallel planes at varying depths during logging operations while applying constant voltage gradients. Combined with temperature logging, it provides information on temperature sensitivity, resistivity contrast, and spatial heterogeneity in gas hydrate situations within certain pore geometries. This technique enhances our ability to map regional occurrence patterns of gas hydrates and identify preferential accumulations also with Feisal architectures. AC2 sampling techniques play a crucial function in gathering direct evidence for gas hydrates in their active environment. They offer valuable insights that complement indirect measurements obtained through various drilling and logging methods. Allows an evaluation of in situ fluid and gas compositions released upon depressurization, as well as sample integration times sufficient or stable phase equilibrium calculations. Through integration with resistivity-derived water solidity data, geochemical test results contribute significantly to interpretations of gas hydrate contents, particularly regarding the role of contact fluids in promoting their stabilization. Finally, I want to propose future research cooperation in the field of hydrates between Indonesia Research Center of Geological Resource and the GIMGS. Indonesia possesses significant natural resources, including methane hydrates along its extensive coastlines and the water areas, which present opportunities but also pose technical and economic challenges. Some preliminary exploration programs reward promoting reserves in various regions, such as northwestern Borneo, eastern Kalimantan, promoting further studies. However, not much advancement has been taken place since then. In my opinion, we can cooperate in the following areas in gas hydrate fields. The first one is the science and technology exchange in hydrate exploration and production. Then implementation of joint exploration voyages in marine settings. The third is the technical and the equipment training. The last and most important is the research cooperation, including hydrate accumulation theory, exploration, and exploitation geology. Well, that's about it for now. Indonesia is rich in hydrated resources and has a great exploration and exploitation prospects. I hope to achieve ideal research results in our future cooperative research. We look forward to further exchanges and cooperation. Thank you for your attention.
Thank you very much, Dr. Zhang. A very interesting finding and report from your working group in China. I'm pretty sure that there are a lot of questions from audience, but we keep the question and discussion in the last session. Now we are going to continue to Dr. Syrbu. Nadezhda, are you already here with us now?
Yes.
Okay.
Oh,
So.
yes. Hello.
Okay. So you can share your slide now.
Aris.
Yeah, Aris. Okay.
Yeah. Dear colleagues at once. Today I want to present you for the first time an overview of the study gas hydrates of the marginal seas of the Western Pacific. Okay. POI has high competence and a great experience in marine researches. Many indigenous employees take part in expeditions, for example, from Buryatia and Yakutia regions. We study geology, geophysics, geochemistry, and geomicrobiology of the Pacific, Eastern Arctic, and its mineral resources. Special attention, of course, is paid to gas hydrates, gas geochemistry, and offshore oil formation and mineral natural resources. How the next? Since 1980, and 84, the research team of POI has been involved in oil and gas exploration work on the shelves of the northwestern Pacific Ocean. A method for searching for oil and gas deposits, according to a set of gas chemical criteria, was developed by Dr. Abjir. We discover a sharp increase in the values of background and abnormal concentration of methane in the bottom layer of the northeastern shelf and the slope of Sakhalin Island. The next one. Yes. Our team took part in international projects and Russian projects supported by grants. Gas hydrates in the western part of the Sea of Okhotsk was most fully explored for the first time during these projects. The accumulation of gas hydrates in marine sediments is controlled by a number of physical and biochemical parameters, including the thickness of gas hydrate stability zone, solubility of methane, and accumulation of particular organic carbon and the seafloor, also microbial organic matter. Next one. Okay. Along the western part of the Pacific Ocean, there are many marginal seas associated with destructive crust of oceanic and continental types, the gas hydrate potential of which has not yet been studied. One of the first discoveries of gas hydrates was made on board research vessel Marine Geophysics by POI in the Sea of Okhotsk. Next one, please. Therefore, at the moment, we have several reasons for a complex study of marine gas hydrates in the Indo-Pacific region. Gas hydrates are an important marine phenomenon. Gas hydrates were found in many areas of the Western Pacific and Indian Oceans. Nature and evolution of gas hydrate system in the lithosphere and hydrosphere, which in respect to environmental agent is one of the most uncertain problems. Fluxes of methane are associated with gas hydrates and plays a significant climatic and social role, but remains one of the debated topics. Now we try to organize a long-term collaborative international project in the frame of the Westpac to study gas hydrates in the Western Pacific and Indian Oceans. Next one. We have some precautions. Shallow methane hydrates are found widely. Gas hydrates are associated to oil and gas deposits, coal-based methane, controlled by tectonic sediment features, earthquakes, methane fluxes, flow morphology, and microbiology. We use different methods like hydroacoustic, seismic, bathymetry, coring, heat flux, gravity, magnetic, CTD, and others. And use different approaches like integrated geology, oceanographic and geophysical marine expeditions, modeling, and remote sensing. Next one. POI has a great experience in marine research and studying gas hydrates in the frame of international programs and Russian Science Foundation. Next one, please. We conduct all seasons marine expeditions. Next. Methane hydrates was explored since 1860s in the Sea of Okhotsk. Gas hydrates supplying fluid within the 6 Cainozoic sediment basin are linked to hydrocarbon accumulations, mainly oil and gas deposits and gas hydrates, provided for the Bering, Okhotsk, and Japan seas. Next one. Western and eastern margin of the Pacific Ocean presents numerous gas hydrate sites distributed as gas hydrate provinces, which can be combined in circum-Pacific gas hydrate rim. Gas hydrates accumulations introduced by various active geological features determined by geodynamic and tectonic types and seismic state of Pacific and adjoining lithosphere plate borders. Bering Sea, Okhotsk Sea, Japan Sea, East China Sea, South China Sea, Tulu Seas, and southward to New Zealand offshore presents Western Pacific gas hydrate rim and exposed methane hydrates distribution in sediments. Next. Gas hydrates in Japan Sea and Sea of Okhotsk originate from gas flux from interior gases and combinations. Next, please. Gas flares within Western Kuril Basin slope were registered at the depths from 2,000 meters to 200 meters. The maximum concentration was observed in the northern part of the Kuril Basin. Gas flares were located near the shelf brick. One gas flare was found near the southern frame of Kuril Basin at depths of 2,020 meters. It is the highest flare among all known gas flares on the East Sakhalin slope. Next one. Thank you. Submarine gas seepage usually accompanied by contrast seismic and acoustic anomalies in the sediments and water column. For example, about 700 gas flares indicates gas hydrate types and accumulation in the Okhotsk Sea. Next one. Here you can see location of revealed gas hydrate accumulations and some gas flares in the northeastern Sakhalin slope, in the western slope of the Kuril Basin, right here, and near Paramushir Island, and that refers to the main fault zones. Gas hydrates and related methane fluxes are controlled by Eastern Sakhalin Fault System and Hokkaido-Sakhalin Fault System, which are pathways for deep buried gas migration. Next one. The most intensive methane anomaly fields in the water of the Okhotsk Sea, exceeding a background in 1,000 times and more, are formed on the northeastern shelf and slope of Sakhalin. Gas bubbles create anomalies with maximum values about 20,000 nanoliter per liter near the seafloor and about 1,000 nanoliter per liter near the sea surface. Next one, please. Methane fluxes from gas hydrate decomposition created sound scattering flares, the acoustic anomalies of various forms in echograms. Methane migrated via fault zones to the water column like seep without acoustic anomaly from oil and gas bearing layers. Next one. The observations were carried out on board research vessel Academic Levent by hydroacoustic system based on the echo sounders ELEC and Sargan M. Next one, please. Here you can see echo sounders Sargan M and sonar Sargan L GM and its characteristics. Next one, please. This is a block scheme of hydroacoustic system and its configuration and different vessel speed. Next one, please. And this is a digital registration system is designed for collection initial data, processing data, storage, and visualization. Next one, please. Okay. The Bering Sea closest is the next, and its closest part of the transition zone of the Western Pacific Ocean. The Aleutian and Bowers deep water basin seems to be the most promising in terms of gas hydrate content. Potentially high hydrate bearing structures found in zones of tectonic faults. Methane manifestations found in front of the zones on the coast, like this. The gas content in sediments in the continental part of the Bering Sea is also due to the presence of coal deposits, which may be a source of high hydrate forming methane. Next one, please. This is the hydroacoustic anomalies above the sources of methane, like gas flares. Next, please. This is the gas hydrates and sediment cores in the Bering Sea. Next one. One of the most representative gas hydrate bearing provinces of the Pacific Ocean is located in the Sea of Okhotsk. Underwater gas hydrates have been studied here using remote seismic and sonar surveys and confirmed by direct methods. In the Sea of Okhotsk, compared with other basins, gas hydrates are often represented by massive samples, lenses, and interlayers, with a capacity about first 10 centimeters. Next one, please. An example of methane sources location. This is an example of the methane sources location along the linear tectonic zones. The next one. Currently, along the eastern slope of Sakhalin Island, the area of actual distribution of gas hydrates is about 15,000 square kilometers. Next one, please. Natural gas flows in the Sea of Okhotsk associated with gas hydrates are among the most active modern ones. Methane rises the upper part of the hydrate-bearing sediments from the gas generation and gas accumulation zones within sedimentary strata up to 10 kilometers Some of them are subject to fluid processing on the destructive foundation in tectonic deflection. Large gas hydrate-bearing crevasses are identified in the Okhotsk Sea. Among them, there are the northern eastern slope of Sakhalin. This is the Dirgantara Basin. Paramushivsky site, Galiginsky deflection, the western slope of the Kuril Basin, and potentially hydrate-bearing area near Hokkaido Island. Next one, please. Many active gas and fluid venting sites on the seafloor, lots of methane releases into the water column, and massive gas hydrate deposits have been found on the northern Sakhalin slope. The main factor determining the spread of gas flows are tectonic faults constricting zones of gas-saturated sediment. Next one, please. In general, sources of hydrate gas in Sea of Okhotsk are a mixture of microbial and thermogenic methane. Gas hydrates are formed due to the flow of methane of mixed genesis, microbial and thermogenic, forming clusters. The initial gas stream feeding the microbial communities forms the underlying sediments with a substrate is thermogenic, according to the geological and biochemical data. Next one, please. The gas hydrate-bearing site on the northeastern slope of Sakhalin Island in the upper part of the section is composed of sediments formed under the influence of the Amur River. Next one. Let's discuss about Japan Sea. In the Sea of Japan, gas hydrates are found on the slopes of Sakhalin, Honshu, and Hokkaido Islands, and in the Tsushima Basin. Oil and gas basins located on the coast and shelf, coal deposits in the field of the Green Tubes formation created a high gas potential for the formation of gas hydrates in this area. Next one, please. This figure shows accumulation identified by Japanese researchers as zone with a high concentration of gas potential. Next one, please. The most intense methane fluxes on the water atmospheric boundary are observed on the gas-bearing southwest shelf and gas hydrate-bearing slope of Sakhalin. The calculation model has shown that formation of increased methane emission from the sea surface is located in the areas with a possible vertical migration from lithosphere sources. The role of hydrodynamics in the formation of those zones with increased methane emission from water area is subordinate to geological factors. Next one, please. Found first in the world experienced gas hydrates research in north of Japan Sea on the depth about 300 meters, the most shallow gas hydrates in the world ocean. As we found from Okhotsk and Japan seas, gas hydrate also accompanied by helium anomalies, which are linked to the deep geological structures. Those results were detailed and confirmed by a number of marine cruises on board research vessel Academic Lavrentiev. Next one, please. Let's go to the East China Sea. The East China Sea is little studied with respect to gas hydrate potential and is not as promising as other ones. But carbon dioxide hydrates were discovered in the Okinawa Trough. Methane hydrates are also assumed according to seismic methods on the slope of Honshu Island. Next one, please. The isotopic composition of carbon methane gas hydrates has a thermogenic genesis with a mixture of microbial components. The most north accumulation of gas hydrate in the South China Sea was found in the southwestern water area of Taiwan. The next, please. Next, please. Next. The South China Sea, no.
You want to go back? Or?
Go back, please, go back. Okay. The South China Sea has a significant oil and gas potential. Integrated geological and geophysical expeditions to the South China Sea were organized by POI on board research vessels academic Nesmiyanov, Morskoy Geophysic, and Professor Gogover, and the last one, the academic Lavrentiev. During the expeditions, anomalous fields of methane, heavy hydrocarbon gases were discovered, which combined with geophysical studies positively characterize the prospects for oil and gas. During the joint Russian-Vietnamese studies in the South China Sea, manifestations of new hydrocarbon accumulation zones were discovered. Excuse me, could you give the back one? One step back. Yes, thank you. A unique zone where accumulations of ferromanganese crust and nodules were revealed for the first time. The ekaite mineral that serves as an indicator of methane migration zones was discovered in the Wuhan Basin, like here. Heavy concentrations with these indicators of rare forms of ore mineralization were collected. Features of methane and mercury fluxes in the atmosphere were detected. Cultures of methane oxidizing, oil oxidizing, and sulfur reducing bacteria were registered for the first time within the study of POI. We get a new data on gravity and magnetic field anomalies. The next, please. In 2019, the first complex joint Russia-Vietnamese expedition was conducted in the South China Sea on board research vessel academic Lavrentiev. We conduct gas geochemical studies of hydrocarbon gases and carbon dioxide, helium, and hydrogen in water and sediments of the Namkonsong, Phu Han, and Red River basins. About 50 sedimentary cores were studied. The next one, please. Found ferromanganese formation among the samples of carbonate aggregates at the southern slope. On the central slope of Vietnam, an unusual organomineral aggregate was found, complex in a chemical composition. In addition, at the same station, 3 groups of bacteria were found at once, as well as methane and hydrogen sulfide and abnormal concentration. The next one, please. As the orthogenic formations were identified in the quaternary sediments of the southern China Sea, sulfide, carbonate, and ferromanganese. We justified the abiogenic genesis of pyrit for the Phu Han basins and studied the relation with gas geochemical and microbiological factors. The next one, please. This is the sulfide concentrations found in the gas emission areas of the South China Sea. The next one, please. Bacterial communities of sulfate reduction specialization may have been directly involved in the formation of orthogenic sulfide mineralization. The geomicrobiology survey were conducted on board research vessel. The next one, please. This is the formation of biofilms by oil oxidation bacteria. The next one, please. According to works of Professor Shakirov, the South China Sea is a part of the East Asian gas hydrate Bering Belt, stretching from the coast of New Zealand to the Bering Sea. Bering Sea hosts Japan, East China, South China, and southward to New Zealand offshore exposed methane hydrate distribution in sediments. The concept of the gas hydrate belts allow us to study and compare regional and global regularities of the gas hydrate origin and distribution. The next one, please. According to our researchers, more than one monograph has been written the last time. The next one, please. This is the monographs for the last years. The next, please. The next, please. Okay. Gas hydride resources huge, and we propose comparable study on gas hydride phenomena and developing the Indo-Pacific program in the frame of the WISPAC. Under our working group, complex study of gas hydrates and methane fluxes in the Indo-Pacific regions. We propose long-term collaborative international project to study gas hydrides. Next one, please. We are open to cooperation and call for the development of the marine gas hydride researches in the Indo-Pacific regions of all the scientific levels. Next one, please. Thank you for your attention. Let's build bridges.
Thank you very much, Dr. Syrbu. So, everyone, ladies and gentlemen, if you have any question, you just can raise your hand in Zoom, or we can start discussing some questions we already have in the chat box. So I haven't seen anyone raise their hand, so probably we can start discussion with the one in the chat box. So. Okay, so Pak Hananto already has asked question, but it's already answered by Dr. Zhang directly. But if you have any other question, Prof. Hananto, you can ask directly to Dr. Zhang.
Thank you, Dr. Maruf. I think we already have some discussion in the chat, so I don't think to elaborate here. But I saw the Feisal is raising hand.
Really? Oh, yeah. Okay.
Yeah.
Thank you. So, okay, Dr. Feisal, you can ask your question directly. You still mute. Okay.
Thank you so much for the presentation, Dr. Syrbu. Very interesting. I have one is just a confirmation and one is a question. So in the I guess in the if I read correctly, in the earlier slides, I think there was a point where you mentioned about the gas hydrate stability zones is 50 to 700 centimeter below seafloor. If I read that correctly, is that correct? Because 50 to 700 centimeter equals to a half until 7 meters. That's too shallow. Maybe I'm wrong.
Dr. Syrbu? Yeah, are you still with us?
I'm still with us.
Okay.
The first slides about what's meters.
In one of your earlier slide, I can't remember because there's no pages in the slide. You mentioned about the presence of bottom simulating reflectors around 50 to 700 centimeter below seafloor. Maybe I'm wrong because maybe I was just skipping too fast. But is it correct or not? Is 50 to 700 centimeter?
No, maybe it's my mistake.
It's supposed to be in meter,
just
right?
what mistake? No.
Okay, that's fine. My second question is, based on your experiences, I was wondering if there is evidence of abiotic origin for the hydrocarbon gas in the Western Pacific Marginal Basin.
Yes, we have isotopic analysis of the CO4 host numbers, South China Sea, Bering Sea, and Japan Sea. Some of them are like thermogenesis about minus 40, 45, and some of them are about very microbial genesis, about 65, about 70, 700. And we think that the genesis can be directly found in mixed microbial and thermogenic at once, not one source of the gas.
Okay, so my question was, what about abiotic? Abiotic means it's not thermogenic,
Abiotic.
it's not biogenic. It's due to non-organic decomposition. Have you ever found anything about that, like the one in Alaska or like the one in North Sea?
Yes, we found that one on the northeastern Sakhalin slope.
And do you think in terms of volume, it's more or less, I don't know, economical compared to the one in thermogenic or biogenic cases?
Thermogenic. I think the thermogenic gas has a very great flow compared with microbiologist flows. But now we can take in account more and more microbiology flows, because we now study geomicrobiology more tightly, and it's very interesting and very important process in sediments.
So I think that's all of the questions to you. Nice job.
Yeah. Okay, thank you, Mas Feisal. Thank you, Dr. Syrbu. So we'll see if there are any other question in the chat box. Oh, again, Mas Feisal, you asked a question to Dr. Zhang. Is there any experiences on disassociating the gas hydrate in the subsurface using other methods? I think it's a question to Dr. Zhang. Dr. Zhang, are you still with us? Yes, Dr. Zhang, do you mind to elaborate the question from Dr. Feisal? He asked about, is there any experiences on dissociating the gas hydrate in the subsurface using other methods? Can you hear me, Dr. Zhang?
Yeah, sorry, I can't hear you clearly.
Okay, there's a question in the chat box. It's from Feisal. So,
The chat box.
yes, he asked about any experiences on dissociating the gas hydrate in the subsurface using other methods.
So you mentioned earlier that you use the depressurization to retrieve the gas hydrate, basically. I was wondering if you have other experiences using different methods, such as thermal or inhibitor injections and whatnot.
Yeah, in the production test in China, we only tested the depressurization method to dissociate the gas hydrate. No other methods, such as the thermal injection or carbon dioxide extraction method.
Yeah. Okay. Cool.
Okay, good. Noted. So is there any question from our audience? If there's any question, you just can raise your hand. Oh, while we're waiting question, Dr. Zhang, do you mind to share what is your government prediction on when gas hydrate will be publicly available? It's just it's just a prediction. It's out of science. I'm just wondering, do the government of China predict when it will be available, the product of gas hydrate, to the public? Do you mind to share any opinion concerning that, Dr. Zhang?
Yeah, in the plan of the commercial utilization of the gas hydrate in China, we proposed that it may be come to the commercial utilization in 2030 years.
2030, interesting. Okay. Thank you. Okay.
You're welcome.
And then let's see, is there any other question from the chat box? Okay, now, so while we're waiting for our question, Dr. Zhang, what do you think about your opinion on concerning the possibility on cooperation between the Indonesian researchers and researchers from your institute, especially in the next coming years in the future?
Yes, we hope so. We look forward to cooperation between the Indonesian researchers and in China.
Okay. So I had a question probably for Dr. Susilo. So, I mean, concerning that matter about the collaboration with the foreign researcher or institute. So what do you think our possibility for this cooperation?
I think I completely agree with Dr. Zhang's ideas regarding there are four points to cooperate with us, and we should start soon, because this could be what the first chance for us to learn a lot from other countries, because as we know from this presentation from Dr. Syrbu and Dr. Zhang, Russia and China and probably Japan and Korea are already very advanced in this research area, but we felt left behind in this group of research. So the matter is how we should start this. So we will ask Dr. Iwan Setiawan when he is going to visit Guangzhou next August, will be also mentioning this this cooperation in this field of Methane Hydrate Research, I think. And I hope Dr. Zhang and Dr. Iwan Setiawan can meet in Guangzhou in the next August, I think.
Okay, thank you, Pak Susilo. So interesting to see a good collaboration between Indonesia and China, and also probably with Russia. So I have also a question for the two of you, for Dr. Zhang and Dr. Syrbu. Based on your experience, is the research campaign that was done by your institute, is it fully funded by the government, or do you also have any grant from the industry?
No, our investments are all from the government of China. No industrialization companies have invested.
Okay, noted. And how about in Russia, Dr. Syrbu?
Oh, okay.
Do you mind to share?
Our government fully we have some international grants and government programs for gas hydrate research. Maybe the government is the biggest part.
So is there any contribution from industry on your research?
Promising industry areas is Sakhalin slope, and but now we have only scientific interest in this area.
Okay, noted. Thank you. Okay, let me see if there are any questions from the chat box. While we're waiting, probably I have a question for Dr. Feisal, Mas Feisal. Do you mind to share with us what is actually you show us about the several type of the gas hydrate plate type on your slide. So do you mind to remind us about what is actually the geological factor that controlling the different play types in the area, and also what is the implication of the different play type that you found on that area to the exploitation step?
Okay,
Probably you
let
can,
me
yeah, remind us
share
about that.
again.
Yes, that is the first play type. So I was wondering what is actually the geological control or anything that control the different play types of gas hydrate in your
Oh,
area.
yeah, that is a very good question. That is something that I would like to address later in my research. So the study area itself is situated in a very unique situations because to the west of the study area, we have more or less, maybe I need to put it on screen. Wait a sec. Okay, is it clear now?
Yes, it's perfect.
Okay. Yeah, so the study area itself is very unique because to the west, we have the area of more or less, it was in the area of the rifted, failed rift system. But to the east, we have the fault and thrust belts. So they're pretty much controlling the gas hydrate play types. And in this case, it is very interesting because gas hydrate is one of the example of unconventional petroleum systems, meaning that gas hydrodes can be found in a very unique settings. We don't necessarily need to satisfy the petroleum systems just like in a conventional one. So for example, in this case, for the basin margin type, as long as we have a basin that has the margin itself is inclined, so we will assume that the thermogenic gas or the biogenic gas will have the possibility to migrate along the inclined beds, and then as long as the temperature and the pressure conditions suitable, so we will have the DSRs, just like in this basin margin type. And then for the polygonal fault types, it is situated, so this one, the first type, is situated to the, I believe, to the northwest of the study area. This one is located to the west of the study area. So there are, to the west part of the study area, there are lots of polygonal fault types. It is pretty common. If we go deeper in terms of times, we will also see the extension of a mass transport complex. So these two features, the polygonal faults and also the MTC, tells us that there probably this area is it's mainly controlled by the gravity-driven differential compactions, hence the polygonal faults. And then for the other types, this is located to the northern part of the study area, so where we have the buried carbonate mound types. So in this case, it is also controlled again by the past tectonic environments. In this case, I haven't delved into the details regarding what was the implications and also what will be the effect on the exploitations, to be honest. So that is something that I need to take account in the later stage. And then the slope types, it is pretty much everywhere in terms of gas hydrates, especially in the passive margin. So in this case, the slope type is commonly occur in the passive margin, but also in sometimes and also in the active margin. And then the last one, the second last one is the sediment waves types. Yes, we did see this particularly in the deep sea environment. We also have it here in the passive margin in the northern China and the northeastern China. Northern South China Sea and northeastern South China Sea, where gas hydrates, according to references, they are related to the presence of the sediment waves. And last but not least is the plate types related to the fault and thrust belt. So this is related to the eastern part of the study area. So in terms of your questions, your very lengthy question, I would say that by describing the play types in the study area, we can actually see the contrast between the the more active regime versus the more or less passive regime. But in terms of how it will influence the gas hydrate preservations is something that I cannot do it or justify it alone by using seismic. I wish we have more data in terms of well logs and also let's say maybe multi-beams, for examples. But I think that's the answer that I can share with you as for now.
Thank you, Dr. Feisal. Well noted. So we'll see if there are any questions from the chat box. Oh, while we're waiting, actually, I have one question extra for Dr. Syrbu, if it's okay, if we still have time. So you mentioned about the working group on gas hydro and the Pacific Rim. So it's actually, what is actually the main goals on your working group in the Pacific? You still muted, actually. You're still muted.
Okay.
Okay.
Can you repeat, please, about working group?
Yes, but your working group working on the gas hydrate Pacific belt or rim or something like that. So do you mind to elaborate more about what is the main goals on the study of your working group on that?
Main goals? We are working in geochemistry and geomicrobiology about gas hydrate and non-gas hydrate areas and compare these areas and find new features and new relations about with geochemistry, geological process, and microbiology. Maybe this is a three-direction: geochemistry, microbiology, and geology.
Okay, thank you. Thank you for your answer. Okay, probably Pak Kapus, are you still here? Do you have anything to ask to the presenter related to the possible collaboration? Oh, we have Pak Awang.
Please, Pak Awang first.
Pak Awang.
Yeah.
You can ask directly.
I have two questions. First one for you from BRIN. In the former time when we have still BPT or Marine Geological Institutes, the research of the gas hydrate become the responsibility of BPT. So what is the progress of research for gas hydrate after BPT become part of the BRIN? So that is the first questions for you, Pak Maruf. And the second question to Mas Feisal Dirgantara. From your plate type, so it means that the gas hydrate can, the origins of the gas from the gas hydrate can be in situ, sometime like the biogenic gas that become condensed to become hydrate, and also the transported gas that come from the thermogenic and then trapped by the cap rock of the gas hydrate. Thank you.
Thank you, Pak Awang, for the question. For the first question, actually, I don't really have the answer for that. Probably Pak Kapus will have a better answer for that, or Pak Susilo, probably here, who has many experiences working on the marine geology. Could you elaborate the question from Pak Awang about the development of the...
Thanks for the very good question. Well, the first question is, well, in fact, it's not easy to answer, because as you know, the research financial in the BRIN is completely competitive, and that's why we are involved in the, since the BRIN was founded in 2 years ago until probably next 5 or 6 years, we are just looking at the gas hydrate based on the existing seismic data. But even though it's not easy for us, because most of the data belongs to the Ministry Energy and Mineral Resources, and we have no easy access to them. We have to make some kind of arrangement, some kind of MOU, etc. And this is the problem for us. And so at the moment we just collaborating scientist to scientist between BRIN and NTI. And for example, I myself came from NTI, and of course I have some inherited relationship with the NTI in this case, so it's not too difficult for us. But beyond that, probably it's not easy for us, and because we have to collect another data from another area, and it's probably has got better potential of the or in the finding of the methane hydrate in this case. So it's not easy to answer. Probably we still need some kind of way to make this easy for us to refill the gas heater in our country. So that's it, and we still try. That's why I propose if we could make some kind of working group between scientists in Indonesia interested in gas heater research, so we can learn research regarding our interest, also looking at our data, because I know that many seismic data, for example, will be just sparse between in every city, and BRIN itself, in fact, what we can put is has no data in this case. That's the problem. So that's it. That's the answer.
Okay, Pak Susilo. Terima kasih. Thank you very much. So Pak Wang, are you happy with the answer? Otherwise, we have Pak Iwan here. Probably we can elaborate the question from Pak Wang. It's a question for all of us actually.
Thank you, Pak Maruf. Actually, I couldn't hear what Pak Wang said before because I'm still working with some papers. I'm so sorry, but actually, in the near future, we will have a memorandum of understanding with the Ministry of Mineral and Energy Resources. We will establish our agreement with ESDM. Then we will have more easier access to get the data from the resources. Yeah. So I hope after this webinar, we can elaborate, we can have more discussion, we can have more intensely discussion among the Indonesian researchers and as well as international researchers regarding the methane hydrates from Guangzhou, Zhang, and also from Syrbu. I hope we can still have more discussion about the future collaboration. I think that's all, Pak Maruf.
Yeah,
Okay.
Pak Iwan, as far as I know, actually Ministry of Energy and Mineral Resources has ever government regulations for company work in gas hydrate under unconventional hydrocarbons. But I think we should know first about the progress of the gas hydrate research first in Indonesia, in which status before any company interesting to work on that.
Yeah.
So that I asked what the status of the progress of this research.
Yeah. Thank you, Pak Wang. Yeah. We will have an agreement. Then after we have the agreement, so we'll have new information about the status of the methane hydrate exploration in Indonesia. So later on, we will talk more with Pak Wang as well and with our colleagues to expand more collaboration. Thank you, Pak Wang.
Thank you, Pak Iwan. Pak Susilo, thank you.
Okay, thank you. And for the second question, maybe Mas Feisal, you can answer it.
Yeah, sure. But before I answer it, just wanted to let you know, Pak Wang, that I'm such a huge fan of your work, and thank you so much for being such an inspiration for young geoscientists like myself. And actually, in my earlier talk, I did quote your 2007 IPA manuscript, I believe, which you mentioned that in the Makassar Strait, we have both origins of the hydrocarbons from thermogenic and biogenic. So I am aware that the locations are not necessarily the same as in the South Makassar basins, but that is by far the reference that I could get. So to answer your questions, it's actually just repeating your own questions and your own answers. So the answer is yes, because I'm quoting to your paper.
Thank you, Mas Feisal.
Oke, thank you, Mas Feisal. Terima kasih, Pak Wang. Okay. Baik, sepertinya seems that we don't have any more questions, so probably we come to the end of this talk. It's very interesting and lengthy talk. We are very lucky to have three distinguished speakers who share their knowledge on gas hydrate. Dr. Feisal Dirgantara just started his work on methane hydrate in Indonesia. I hope we'll see his progress in the future, and also working with his group in geodynamic group. And for Dr. Zhang and Dr. Syrbu, we are very appreciate your availability to share your knowledge on the gas hydrate. And I'm looking for the ambitions of the Chinese government to see that gas hydrate will be available for public in, you said, in the year 2030. That is very impressive. So, and also for the, we are hoping to have a good collaboration between Indonesia, especially from our institute or any institute in Indonesia with China and also with Russia. So I think it's the end of this talk. So I would give the time and to the committee. Thank you, everyone.
Thank you.
Thank you. We would like to thank you to Bapak Dr. Maruf Mukti and all distinguished speakers for bringing us to a very productive session today. So, ladies and gentlemen, we are currently in the closing session. We would like to remind you that link to the attendance report form is now available and active. The link has been embedded in the chat column. And on behalf of the committee in charge, we would like to express our apologies we made during the event. Thank you very much for your active participation today, and have a great rest.